Okay, so far we have talked about special right triangles in section 2 and Pythagorean theorem in section 1. In section 3, we are talking about similar right triangles. So we're going to use some of the same types of things that we talked about in chapter 8 with similar triangles. The difference is that all of these are going to be right triangles now. So our right triangle similarity theorem is our main theorem for this section. Basically, we're going to have one entire right triangle. So that would be this triangle ABC that I am outlining in red. And basically what we're going to do is we are going to draw an altitude. Remember, an altitude just starts at a vertex and goes straight down to the other side, forming a right angle. So I will quickly just highlight that in yellow. So we've got that altitude CD that is splitting that right triangle ABC into two smaller triangles. So now we have this triangle here in blue, triangle ACD, and then we also have this triangle here in green, triangle CBD. So we now have 3 triangles. We can split those apart to make it a little bit easier to look at. But the key with this is going to be to matching up your corresponding sides or your corresponding angles. Mostly sides. We're mostly going to be looking at sides here. So when we think about this, we'll kind of look at the 2 triangles separated. In this triangle on the right, CDB, DB is the shortest side of that triangle. And on the triangle on the left, ACD, DC is the shortest side. So essentially those 2 would be the corresponding sides. And then CD is the next longest side, which is going to correspond to AD in the other triangle. And then our 2 hypotenuses, so CB and AC. So what you need to know is that those 3 triangles, okay, so 3 because we have our main triangle that we started with, ABC, the original, and then the 2 triangles it turns into, triangles CBD and triangle ACD, those are all similar to each other. So they have those similarity statements separated, but you could also write them as one whole similarity statement and say triangle ABC is going to be similar to triangle CBD, which is also going to be similar to triangle ACD. They're all similar to each other. You can write them separately like they did here, or you can write them all as one like I did up here at the top. But they're all similar. So what we want to do in 1 and 2 is just identify the similar triangles. So honestly, the easiest thing that you can do is match up the corresponding pieces, the shorter sides, the longer sides, and all of that. So you know what order to write them in. So let's just start in number 1 with the whole triangle. So I'm going to say that whole triangle is QSR. So I went the shorter leg to the longer leg hypotenuse last, essentially. So shorter leg to the longer leg. So we want to make sure that we are doing that with the 2 smaller triangles. So if we ignore the bottom triangle and just look at this triangle up in the top left corner of that, we're going to go shorter leg to longer leg. So our shorter leg in that triangle would be QT. The longer leg would be TS. So we're going triangle QT to S. So shorter leg to longer leg across the hypotenuse. And then do the same thing with that bottom right triangle. So if we have a right angle on this side over here, then we know this is going to be a right angle. And then just to change up the color to make it a little bit easier to see, our shorter leg is going to be ST. Our longer leg is going to be TR. And then we go across the hypotenuse. So S to T to R. Now I would encourage you to go ahead and try number 2 on your own. Start with that bigger triangle. Use one of the smaller triangles, match up the shorter leg, the longer leg, and then your hypotenuse, or whatever order you go in with your first triangle. So I would encourage you to just pause it, try it on your own, and then compare to mine. Now, the order that you write it in does not matter as long as it's corresponding. So like in number 1, I did the short leg to the long leg. If you did the long leg to the hypotenuse to the short leg, that's fine. As long as you're following the same order, your corresponding parts are listed, that does not matter. So in number 2, for that whole triangle, I'm going to say E to F to G. So hypotenuse to long leg to short leg. And we'll just erase that to make it easier to see. And then I'm going to start with my triangle on the left. So I did hypotenuse, long leg, short leg. So my hypotenuse on this triangle on the left is this side EG, and my long leg would be GH. So I'm going to go E to G to H. And then I'm going to do the same thing with the other triangle. I'm going to start with my hypotenuse, and my longer leg here is FH. So I'm going to go from G to F to H, so that it's hypotenuse, long leg, short leg. So don't panic if yours is not written in the exact same order as mine. As long as your corresponding parts are matched up, that's okay. So if you said FEG, you would just want GEH and FGH. Or GFE would just be HGE and HFG. So the order doesn't matter as long as they're in corresponding order. So in 3 and 4, we're solving for X. We're solving for our variables. So we just want to match up corresponding sides. So it does not matter what side you pick, which 2 sides you pick, as long as you have corresponding sides that you're setting them equal to. So we're just doing a proportion here. So this is exactly like we would have done in chapter 8. So I'm going to say, okay, well, I'm going to use 3 and my hypotenuse of 5. So I'm going to say, okay, well, that's 3 over 5. Well, 3 is the short leg for the whole triangle. 5 is the hypotenuse for the whole triangle. So I need to then use one of the smaller triangles where I have the short leg and the hypotenuse. So if I'm looking at these 2 smaller triangles, X is the long leg for this triangle up above, and it's the shorter leg for this triangle down below. So since I use short leg over hypotenuse, I need to use short leg over hypotenuse for the triangle that gives me that information. So I'm going to use X over 4. The short leg of this triangle, GHF, and the hypotenuse of that triangle GHF. So I'm just cross multiplying. So 5x, 3 times 4 is 12. When I divide, I just leave it as 12 over 5 because that doesn't simplify. If it told you like round to the nearest whatever, then you can write it as a decimal. Otherwise, leave it as a fraction. Sometimes it's a fraction, sometimes it's a whole number. Either way is fine. Okay, so if you feel confident trying number 4 on your own, go ahead and just come back to see what I ended up finding for x. If you don't, that's okay. Just watch another one. Okay, so I'm going to say, okay, well, I used my short leg in number 3, so let me use my long leg in number 4. So 12 is the long leg, longer leg. 13 is the hypotenuse of the entire triangle. So I need to set that equal to the triangle, the smaller triangle that gives me the longer leg and the hypotenuse. Well, if I'm looking at x, this is the longer leg for this smaller triangle here. So the longer leg of x, the hypotenuse of 5, and I'm just going to cross multiply to solve for x. So 13x equals 60. 12 times 5 gives me 60. I'm going to divide by 13. And once again, that's just not going to simplify, so we're just going to leave it as 60 over 13 unless it specifically asks us to round. Okay, so for both of these, we're just setting a proportion up like we would have in chapter 8. Nothing changes. We're matching up corresponding sides, setting them equal, cross multiplying. Okay, so geometric mean, there's nothing special about this, like in terms of like a trick or anything. It's just a matter of, like, if you're asked to find a geometric mean, it's a little bit different from a regular mean, because a regular mean, we are adding everything up and dividing by the total number. A geometric mean, we're just taking two numbers and turning them into a proportion. So let's just say we had two numbers of 4 and 9 that we needed to find the geometric mean for. We would just say 4 over x, so 4 would be like A, 9 would be like B. So we're plugging in for A and B. So 4 over x is going to equal x over 9. We're going to cross multiply, which is going to give me x squared equals 36. And then to get x by itself, we're just going to take the square root of 36, which just leaves us with 6. So that geometric mean for 4 and 9 is just 6. We have two more theorems. These two theorems look much more complicated than they really are. It is all still a matter of proportions that are corresponding sides. They write them as geometric means after you would have essentially cross multiplied. I think that's more confusing. If that works for you, you are welcome to do that. But I'm going to give these each part variables. So, I'm just going to call this X and W and Y. Okay, so for this first theorem, if we're finding an altitude height, we want the two pieces of the hypotenuse, the original hypotenuse. So basically it's just a geometric mean of those two pieces of the hypotenuse. So we would have W over X equals X over Y, which is where they're getting that CD squared, because if we cross multiply this, we have X squared, which I represented CD with the letter X. So that's where they're getting that CD squared equals AD times BD. But one, I don't like using the vertices because it can get very jumbled up and very busy and harder to understand what's happening. And also, we've been doing proportions for so long, if you can look at it as corresponding parts, it's much easier. So we're looking at the two smaller triangles individually. So the triangle on the left, we've got the longer leg over the shorter leg, W over X. If we look at the triangle on the right, in order to do the longer leg over the shorter leg, it becomes X over Y, which is exactly what we have here. When we look at Theorem 9.8, if we're finding a leg length, which would be like CB or AC, well, here, okay, I'm going to say that AD is W, and we'll call DBU, and then we'll say that AB, that entire length, is Z. So when you're finding a leg, it looks much more jumbled because they have it written in two different theorems, two different equations. But it's the same thing. We just want to set up a proportion with corresponding parts. So if we want to find the length of X, what we're going to do is we're going to say, okay, I'm going to look at my triangle as a whole, and I'm going to say that my short leg, which would be X, over my hypotenuse, which would be Z, because it's the entire triangle. So it's this side X and this side AB. Okay? I'm going to set that equal using the smaller triangle, but that smaller triangle is going to have to be the one that has X in it. So short leg over hypotenuse is going to be equal to the short leg in that triangle that's smaller, which would be U, over the hypotenuse of that triangle, which would be X. So it's just corresponding parts. Or for the other leg, if we're looking to solve for Y would be the long leg over my whole hypotenuse, so Y over Z. Now we're going to ignore the smaller triangle on the right because we just need to use that smaller triangle that still has Y in it. Okay, so I did the longer side over the hypotenuse. So in this triangle over here, my longer leg is W over the hypotenuse, which is Y. So you're just setting up your corresponding sides. You're not generally going to have every single side essentially filled in like I labeled in the second theorem. It's usually just what you need plus maybe one extra, but just match up your corresponding parts. If you can match up your corresponding parts, you're going to get the right answer every time. Okay, so we're finding geometric means in 5 and 6. So remember, to find your geometric mean, it's your number over X equals X over your second number, and you're just solving that proportion. So go ahead and try both of these on your own. Pause the video, see what you can get, come back, hit play, and then see how your answer compares to mine. So in number 5, I've got 12 over X equals X over 27. When I cross multiply, I've got X squared equals 324. I'm going to take that square root and I'm going to get a geometric mean of 18. When I look at number 6, I'm going to do the same thing. 16 over X equals X over 18. I'm going to cross multiply to get X squared equals 288. Now, I haven't paid enough attention to the homework for this section yet to realize if it wants an exact answer or a decimal answer. 288 is not a perfect square, so if it wants a decimal answer, just make sure you round it appropriately. if it doesn't want a decimal answer, if it doesn't want a decimal answer, you just want to simplify your square root. So we're going to try to get this simplified down as much as we can. Now, I posted a video with how to simplify square roots the other day in Google Classroom. If you need to go back through and watch that, go back through and watch it. But basically, we're just looking for perfect squares. So 288, 16 was a perfect square. So we could turn that into 16 times 18. The square root of 16 is 4 times the square root of 18. Now we just need to look at 18. Well, does 18 have any perfect squares? Yes. 9 times 2 is 18. 9 is a perfect square. So 4 times the square root of 9 is 3. So 4 times 3, square root 2. Just simplify that. 4 times 3 to get 12. Tack on your square root 2. And that would be your geometric mean. The last thing in this section, we're just looking at 7 and 8. We're solving for the variable. So we're using those last two theorems. So just set up your corresponding sides. Okay, so if we look at the left triangle first in number 7, x is the longer leg, 4 is the shorter leg. So longer over shorter gives me x over 4. And then if we come to that other side of the triangle, our longer leg is 9, our shorter leg is x. So geometric mean, really when it's just the altitude, but we're cross multiplying, x squared equals 36. We take that square root and we get an altitude height of 6 for x. Same thing in number 8. So remember, when we're finding a leg, we're going to use that leg that we need to find in the whole hypotenuse. So if this piece is 2 and this bottom piece is 5, that's going to give us an entire length for that hypotenuse of 7. So the shorter leg of the whole triangle over the hypotenuse of 7. Now we're going to look at that triangle, smaller triangle with y in it. Our shorter leg is 2. Our hypotenuse is y. And we're just going to cross multiply and solve. So y squared equals 14. We're going to take that square root. So 14 doesn't have any perfect squares. So if it asks for an exact answer, we're going to leave it as the square root of 14. If on your homework it asks you to round to the nearest tenth or something like that, that's when you would just plug that into your calculator and say that it would be about 7.4. So remember, exact answer is a simplified square root. Rounded answer is going to be with your decimal. Okay, so your homework will be on big ideas. If you need me and it's during that hour of our block time, join our Zoom, the Zoom conversation. If you need me and it's outside of that Zoom time, either send me an email, request a Google Meet, whatever you need to do to get a hold of me.